influence of aging process on the population of the T and B lymphocytes. At the cellular level, the activation potential of T cells is altered in old age, leading to a hypo-responsiveness. This has been well documented in animal model and human studies of the CD4 T cells, and has been attributed to alterations in formation of the immunobiological synapses between T cells and antigen-presenting cells, as well as to signaling defects. Age-related changes in lipid raft polarization have recently been suggested to represent an important cause of age-related changes in CD4 T cell signaling. Cytokines are a key component in the regulatory communication process among immune cells in general and T cells in particular. Age-related changes in cytokine production have been studied for over 20 years. The long-standing notion that interleukin-2 production decreases while interleukin-4 production increases with advancing age has recently been challenged by reports indicating an increase in pro-inflammatory activity in all organs, which seems at least partly due to the increase in the whole body load of the interferon gamma. The increase in the production of the interferon gamma is possibly the result of the accumulation of terminally differentiated CD28- T cells with a high pro-inflammatory activity, which is found in large subgroups of elderly persons. In contrast, high interleukin-4 production, which is observed in other elderly cohorts, correlates with a high number of central memory T cells, but a low number of effector T cells. Like the T cell pool, the peripheral blood B cell pool fills up with memory cells owing to a concurrent displacement of naive cells. The percentage of naive B cells, which are defined by the absence of the CD27, is significantly lower in the older than in the young individuals, where the opposite is true for memory cells. The production of peripheral blood B cells is similar in elderly and young people, although there is a trend towards a slower rate of B cell proliferation in the elderly. Similar to the T cell population, aging is associated with the appearance of B cell clonal expansion. This limits the diversity of the B cell repertoire and may induce monoclonal serum immunoglobulins and B cell neoplasms. Additionally, there is a shift from B2 to B1 lymphocytes. Most foreign protein antigens stimulate B2 cells in the presence of the T helper, whereas carbohydrate and antigens do not depend on T cell help and stimulate B1 cells. Age-related changes in the B cell population result in impaired humoral immunity in elderly people. Primary antibody responses in elderly people are often weak and short-lived, and the antibodies produced bind with lower affinity. Antibody production in response to vaccination has been extensively studied in older people, and it has been suggested that the protective effect of vaccinations against infections such as Streptococcus pneumonia, influenza, hepatitis B, and tetanus reduces with age. Old age is also associated with an increased occurrence of autoantibodies. However, these autoantibodies lack specificity for organs and rarely contribute to autoimmune disease. Although age-related changes in humoral immunity may be the result of intrinsic defects in B cells and changes in the B-cell repertoire, the lack of the regulatory control of T cells and B cells also contributes to the low level and brief production period of specific antibodies to foreign antigens in the elderly. On the cellular level, immunosenescence is characterized by neutrophils exhibiting reduced activity, including reduced phagocytosis and clearance of pathogens, altered chemotaxis, poor antigen presentation capacity, increased free radical production, and apoptosis of immune cells. This occurs due to alterations in key pathogen receptors, the Toll-like receptors, especially TLR1. Hence, there are some novice therapeutic strategies for which target specifically target Toll-like receptors. These changes are mirrored in monocytes and dendritic cells, which are the crucial antigen-presenting cells. NK cells gradually lose their cytolytic function. A highly differentiated memory T cells accumulate in older people as a consequence of lifelong infections and antigens that have been encountered with a reduced off-repertoire diversity for naive T cells. T cells undergo a decline in the amount of the CD4 plus memory T cells and reduce cytolytic properties of the CD8 plus cells. In aging B cells, there is a decrease in class switcher combination, the process that generates protective antibodies and memory B cells. Further, authors of this book present data regarding influence of various factors on the occurrence and progression of the immunosenescence. For instance, such as correlation between metabolic syndrome, obesity, and diabetes and immunosenescence. Neurodegeneration, atherosclerosis, response to vaccinations, and so on and so forth.